Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on September 2nd, 2025, just yesterday. The main punchline is simple and bold. By filtering out trajectories with void turns, the method stabilizes multi-turn tool-integrated reinforcement learning and boosts AIME24 accuracy from 22.1 to 50.5 using the QN 2.57b base model. The paper is titled SimpleTIR, End-to-End Reinforcement Learning for Multi-Turn Tool Integrated Reasoning, and the implications for model training are quite significant. Beyond stability, the approach preserves diverse reasoning behaviors like self-correction and cross-validation, without supervised fine-tuning. Also, the authors shared an implementation on GitHub. You will find training and evaluation code for multi-turn tool integrated RL, datasets and examples, sandbox setup for code execution, scripts for model merging, multi-node H100 configs, and detailed quick start commands. The README explains instability fixes via filtering void turns and provides inference instructions. Alright, Figure 1 makes the point concrete. Filtering trajectories with void turns stabilizes training and lifts accuracy. The left panel shows AIME24 accuracy rising steadily for SimpleTIR, while the naive multi-turn setup climbs briefly then collapses, which signals failure under tool-induced drift. The right panel tracks gradient norm, a measure of update size, and it stays flat for SimpleTIR, but explodes for the naive setup. These curves illustrate why stable updates matter for multi-turn tool use. So Figure 2 shows why naive multi-turn training destabilizes. The left panel reports AIME24 score rising for single turn, but sliding for multi-turn, which signals performance collapse. The second panel plots gradient norm that spikes for multi-turn because low probability tokens inflate the update. The third panel shows response length shrinking in multi-turn, and the fourth shows code use frequency fading towards zero. Together, these statistics indicate a compounding drift. Alright, Figure 4 explains the fix in one glance. Filter any trajectory that contains a void turn, so the policy update only learns from valid multi-turn tool use. A void turn means the model produced no complete code block or final answer, which signals drift and unstable gradients. The pipeline shows interaction with the tool, then trajectory filtering, then reinforcement learning on the remaining clean data. This simple gate reduces exploding updates, because low probability failures stop contributing to the loss. So, Table 1 makes the payoff concrete. The method delivers top math scores across multiple benchmarks while using multi-turn tool integration and zero RL. This table shows the 7B model reaching 50.5 on AIME24, and the 32B model hitting 59.9, which signals stable gains without supervised warm starts. The columns compare datasets like MATH500 and Olympiad, so the margins reflect broad, not narrow, improvements. Wrapping up, two takeaways stand out. Filtering trajectories with void turns stabilizes multi-turn tool integrated reinforcement learning by preventing gradient explosions, and this stability unlocks strong reasoning gains, like 50.5 on AIME24 with QN 2.57b. The broader implication is practical end-to-end tool use without supervised warm starts. Thanks for listening. I am Alex, signing off.